Hey, welcome back to another live stream from the Scalar Learning Channel. And today we got Nidrox. What's up? Krista. Hey, how's it going? Hola, hola. Today, you students who are here are probably about to take the PSAT tomorrow, I'd imagine, or maybe we're taking it at some point in the future. Obviously, things are still in a bit of state of uncertainty, just making sure the stream audio is coming through. And yeah, we're good. So then, yeah, it's a little bit uncertain. We don't know, but hopefully whoever needs to take the PSAT eventually will be able to. And even if it somehow doesn't happen, this is still going to be really relevant for SAT prep if you are going to take the SAT later on to apply to colleges, which I'm sure most of you probably will. And that's why you are here. And the other good thing to note is I think I've made a couple of videos explaining what the PSAT is all about. But I think the most important thing that I can say right now is that the PSAT math is just like the SAT math. I mean, it's the same thing. This is just a slightly shorter test, 45 minutes on the clock and only 31 problems for the calculator section versus 38 and 55 minutes, but it's pretty darn identical. So this is going to be great. And we got Neil Patel. What's up? Shalom Yifru. How you doing? Can you please do College Panda Advanced? Yes. I know. I think you left that comment on another video, and I saw it, and it's on the list. Don't worry. I'm going to make my way first through the other resource upon the SAT, but I will get to that. Can you post a video on PSAT in October 2020? Oh, yeah, for sure. If that one is up there on Reddit, I will absolutely get that. I did not know that. And hey, what's up, Imam? Welcome. It's your first time. Your school had a few spots, so you couldn't. I'm sorry about that. But let's do. Oh, you're gonna go for the ACT. All right. Well, I'm gonna have more videos on the ACT coming up soon as well. Okay. Yes, I will absolutely be doing. I will absolutely be doing more ACT math. No, I don't do any other subjects, but I'm trying to get some of my other tutors in the mix to be doing different subjects. They're amazing. Should you take the SAT as a junior? Yes, 100%. What if you do bad? It's not the end of the world. You can take it again and again. I often have students take it 3 times, and not necessarily, but you can do that, and then you can submit your best score, or in some cases, super score, meaning take the best math from this one, take the best verbal from this one, and so on. Are there graphing quadratic equations on the SAT? Yes. Okay, so guys, I'm going to jump into this test. Now, normally I like to take these tests for the first time. This one I have done, however, before. It's one of the 2 official practice PSATs on the College Board website. But I will be taking it in real time. Now, again, the reason why I do that is so that you can see me react and respond in real time to things that maybe I get confused about or I have to think about, and how I problem solve and approach each question so I can tackle it and get it correct. You can find honestly, if you just search College Board official PSAT practice test, it'll come up. So I didn't put the link in. Oh, most important thing I forgot to mention. I finally got Discord up, and I'm so excited about Discord. I'm learning about it. And just like I feel like there's a community with people who join the live streams, we're going to make a community in Discord. So if you look in the comment section, in the description, there's the link to the Scalar Learning Discord. And if you're just now starting your SAT, ACT journey, whatever it may be, now is the perfect time, especially if you're here, to join the Discord. So just click on the invite link below, and you can be in there. And I'm trying to build just an amazing community of both my tutors and me. I'll be in there. I'll work with you guys as much as I can, but also hopefully students helping each other. We can have a collaborative space. So I'm so excited about that. So let's do this thing. All right, here we go. We're going to start in 3. Oh, wait, let me get set up here with my pen. Okay. We're going to start in 3, 2, 1, and let's go. A high school counselor conducted a study over 16 consecutive quarters to determine the number of students with part-time jobs. Each student in the 2014 graduating class surveyed once per quarter for all 4 years of high school. The graph below shows the data for each quarter the survey was conducted. During which of the following periods is the increase in the number of students with part-time jobs the largest? Okay, it's looking like somewhere in here. So somewhere from like 6 to 8, 6 to 7, I'd say. Sorry. 4 through 6, no. 7 through 10, probably. 7 through 10, yeah, definitely 7 through 10 has jumped up a lot. Probably the answer. 11 through 14, barely went up at all, right? And then, yeah. There's the winner. Moving on. 2, Eli saves money each month to buy a new computer. The total amount he saved, T, can be calculated by the equation where M is the number of months since he started saving. What does number 83 represent? This is my y-intercept. This means my starting value, initial value, the amount of money Eli started with. Boom, done. Make sure you watch my critical concept video series that talks about how to identify those ones real quick. According to the Department of Agriculture, consuming 100 grams of banana provides 0.15 milligrams of zinc. Got it. So proportion looks like which of the following is close to the number of milligrams zinc per 100. Okay, so we do banana zinc proportion. Let's say 100 banana on top to 0.15 milligrams of zinc. Then we need 140, and we've got x cross 100. X equals, let's do calculator. I can do it 21, but let's do it anyways. 0.15 times 140. Just make sure I don't make a mistake. Equals 21. Divide by 100, and we get 0.21. Boom, done. Numero 4. When the equation y equals 5x plus p, where p is a constant, is graphed in the xy plane, the line passes through point -2, 1. What is the value of p? Sorry. Line pass. Okay, plug and chug. So I'm going to plug -2 in for x, 1 in for y. 1 equals 5 times -2 plus p. 1 equals -10 plus p. Add 10 to both sides. P equals 11. Number 5 and 6. And refer to the following information. The number of hits and times at bat by players on a Major League Baseball team. One sec. The scatter plot above shows the number of hits and the number of times at bat by each of 20 players on a Major League Baseball team. The line of best fit for the data is also shown. So we've got number of times at bat and the number of hits. It looks like it goes up, which makes sense, right? You're going to have more times at bat. You're going to hit the ball more. Now let's look at the questions. Which of the following statements about the relationship between number of times at bat and... Okay, I think we just basically verbalized it, but it should be number of times that increases. Incorrect. Make sure I read the graph right, but... Of course, I'm sure. Yeah. As the number of times that increases, yes. Number of times that increases, no, because then it would be a flat line if it was constant. Number of times that decreases, no. All right, nice. Next, for the player with 450 times at bat, the actual number of hits. Sorry, for the actual number of hits the player had. This will be a dot. Is approximately how many fewer than the number of hits predicted. That's the line of best fit. So predicted would be the value of the line of best fit, and actual is the actual data point. So here's 450, right? Here's the guy right at 450. You could say arguably that guy, but that's a little bit off. So he has how many fewer than predicted by the line of best fit, and the line of best fit, you see the point is right up here, so not too far above. And then now I got to look at the thing. So I'd say that's like, it's approximate, right? But we're saying he's right in the middle. Let's say 113 approximately. And we're saying the line of best fit is maybe 122. So maybe 9 or maybe 10. Boom. Okay. There's our winner. So very clearly has to be 10. Yeah. It's 25. Yeah. No way it's 20. All right. Moving on to number 7. An advertisement states that printing rate of certain printers, 400 characters. Another rate question, 400 characters per second. According to the convention that one word consists of 5 characters, what would be the advertised printing rate in words per minute? So right now, let's do a little dimensional analysis. We have 400 characters per 1 second. Now we need to convert to minutes and words. Now, to convert from characters to words first, it's arbitrary. I can do either or first, but I'll say we have 5 characters. Notice I flip that on the bottom to 1 word, and that's how these will cancel out. Likewise, I need to go from seconds to minutes, so let's flip-flop. We got seconds up here, so these cancel out, and let's make an equivalency, 60 seconds to 1 minute. Now these guys cancel out. Now let's multiply across, 400, boom. Actually, let's simplify first. Let's divide one of these by 5. Let's divide the 400 by 5, and that makes 80. Of course, you can use a calculator if you want. And then I have 80 times 60, which is 4,800. And I'm confident with that. Boom, done. Numero 80. Sorry, my hand's hurting. The table above shows the yearly salary in dollars of an employee at a company. Which of the following best describes the type of model that fits the data in this table? Linear increasing by approximate. Okay, hold on. 1140. Let's see. That definitely goes up by 1140. That does not go up by 1140. I bet it's exponential. Wait a minute. I can figure this out. Here. The first one is 1140. 1140 is what percent of 38,000? Because it doesn't look linear, so I'm kind of discounting these guys. 0.03, there we go. So I bet it's 3%. Now let's double check. Watch this. I'll show you how to do it. 1.03 times 38,000. Well, we already know that's going to be that. And then this, if this shows us the next one, boom, it does. And then let's do it again. And you can see it's going up by 3%. See, there we go. Let's say round up. So there we go. It's going up by 3% every year. Exponential, boom, done. Looks kind of linear because it's such a small percentage gain, but yes, exponential. Which of the following is equivalent to this? All right, first and foremost, let's distribute that negative. Boom, boom, boom. X squared y minus 3. I'm doing the first one first. Just killing those parentheses because they don't do anything there. But the second one does because it distributes a negative. It makes a positive x squared y, a negative 3xy squared. Note these two match up, but just FYI. And then last but not least, a positive 3y squared. Now, these guys kill each other because they're opposites. These guys combine. So I got 2x squared y, which means it's got to be A or C. And then these guys combine to be 2xy squared, and there's the winner. Just make sure I didn't make a mistake. Yeah. 10, which of the following describes the solution to the equation above? All right, first and foremost, I don't want to deal with fractions. Wait, hold on. Okay, first let's distribute this guy. And I got 7 halves x minus 49 equals all this stuff. 1 half x minus 7. Before I even combine like terms, let's just multiply everything by 2. So I got 8x minus 14 equals 7x minus 49 times 2 is 98. This becomes 7x on this side. And then a 7x cancels out. We get negative 14 equals negative 98. No solution. Now, if I would have gotten 14 equals 14 or something like that, that'd be infinitely many solutions. That means the equation will always be true no matter what x is. This means the equation will never be true no matter what x is. Boom, done. Numero 11, the table below shows the monthly electric bills of Joseph and Samuel for the first 5 months of the year. Based on the information in the table, which of these statements is true about the ranges and medians of the bills? Wait, this is going to be... Okay, hold on. Let's first calculate the range. The range for Joseph is 145.30. Hold on, let's use a calculator. It's the biggest minus the smallest, 193. Hold on. 93, 12 minus 145.30 is 47.82. And then this one, the range is 149.23. 188.99 minus 149.23. 149.23 is 39.76. Great. Okay, so we've got the range of Joseph is bigger. Hold on. So that's wrong. Wrong. Range is not less of Joseph. Okay, so it's either B or D. Both range and median. Okay, now we have to find the median. Median is the middle value, so going from least to greatest. So I've got 1. Hold on, let's write it out here. For Joseph, April is 1. That's 2. That's 3. So here's the median for Joseph. And then for Samuel, starting with the lowest, I got 1, 2, 3. Here's the median for Samuel. So the median for Samuel is larger. Median of Joseph, yeah, so it's D. Let me just make sure I didn't make any mistakes with the range. 193 minus that does look like about 47. So I'm just doing a mental check. This one is 188.99 minus that. Yeah, it's about 39. Okay, we're good. Gut check. Next, number 12. The table above presents information about 810 train cars in service on a railroad. Approximately what percentage of the train cars in service are double-decker cars that have been in service for less than 2 years? Okay, give me 1 second. Let me process that again. About 810 cars. Approximately what percentage of the train cars in service Oh, so these are all, that's all of them. So it's just out of 810. Are double-decker less than 10? Double-decker less than 10. So 16 out of, it's got to be 2%. Yep. 2%. So it's basically 1.97% or 2%. I was just making sure I was pulling the right sample size, right? Approximately what percentage of the, so that's the total, train cars in service, which are all, what percentage of the train cars in service are double-deckers that have been in service? Okay. Yeah, I think I got it. 13, a moving company uses plastic wrap to bundle group boxes together. If a portion of plastic wrap that measures 900 inches in length is used to bundle each group of boxes. Hold on, let me make sure I understand this. Portion of plastic wrap that measures is used to bundle each group of boxes. How many groups of boxes? Oh, I get it. So one group is 900. So we say, let's do a proportion. Inches to groups, I guess. So that's 900 inches to one group. How many groups X can be bundled using 1,500 feet? So, of course, we're in inches. That's why we always label our proportions so I don't make the mistake of writing 1,500 here. So it'd be 1,500 times 12, which I believe is 18,000 or 18,000. Boom, boom, boom. Cross, cross. 18,000 equals 900x divided by 900. Again, don't need a calculator if we don't want one. Kill the zeros, kill the zeros. 180 divided by 9 is 20. Number 14. The table below shows the number of calories in cheeseburger at 6 different restaurants. Boom, 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 boom. What is the difference in number of calories in cheeseburger at... What is the difference in number of calories in a cheeseburger at Riverside Diner and the median number of calories in cheeseburger, all 6? Okay, so again, we're hitting that median. Median is middle. So let's rank these guys. 1, 2, not rank order. 1, 2, 3, 4. Notice I'm not rewriting them out in order because this is faster, right? 5 and 6. So now we've got an even number of data points, which means the median is not going to be a specific one. It's going to be in between 3 and 4, right? Those are the middle. So 1, 2, 5, 6 on the outside. So the medians in between those mean we have to take the average of those. So 900 plus 810 is 1710. Divided by 2 is, 855, right? Well, I'm not going to take any chances. 855. So then they said, what is the difference in the number of calories at Riverside and that one? So 1120. So basically this minus 1120, or other way around, but we'll just negate the answer. So negative 265 is just 265. Boom, done. Almost at the halfway point. A circle is graphed in the XY plane that has a radius of 3 and a center of the circle is at 4, -2. Which of the following could be the equation? Okay, radius is on this side, but we're not going to look for a 3. It's radius squared. You just got to have the standard form of a circle memorized. I'll write it real quick. X minus h squared, that's the center x value. Y minus k squared, k is the center y value, and then it's r squared. So it's going to be 9, so we already know that. And it's x should be x minus 4, not plus 4, but both have that. And then it should be y plus 2 because y minus -2. Oh, they both have that. And then it's plus in the middle, not minus. So this is the winner. This one. A high school developed a program called Propel, which offers extra guidance support during 9th grade year. For the school year began, 327 rising 9th graders were selected at random to participate in the study. 109 of those, 109 of those students were randomly assigned to enroll in the Propel program. Wait. 327 were selected at random to participate in the study. 109 were put in Propel. The remaining students served as a control. Got it. So 109 in Propel. And then let me just quickly do 327 minus 109. And then 218 in the control group, which is actually double that. That's cool. Summary of the year-end point grade. 327 who were chosen for the study shown in the table below. Got it. So we've got 61 here enrolled in Propel. Got it. So more than half in Propel were higher than a 3.0. More than half not enrolled were less than a 3.0. So you can see it must have worked. If a 9th grade student is chosen at random, one of the 327, which of the following is close to the probability that the student will have a GPA of 3.0 or greater? So 61 plus 95 out of 327. So any high school student, right? That's why we go with the thing. So it's 61 plus 95 divided by 327 is 0.47, rounded up to 0.48. Beautiful. What was the difference to the nearest whole percent between the percentage of students enrolled in Propel? Wait, hold on. Between percentage of students enrolled in Propel with 3.0 or higher, percentage of students who had a GPA of 3.0 or higher, the percentage of students not enrolled in Propel. Okay, hold on. So this is where I have to think about the phrasing very carefully, because we got to figure out what's our total. What is the difference between the percentage of students enrolled in Propel Okay, so I think what they're trying to, this is how we're trying to do it. So we basically say, I don't even like how they phrased it, but it's a little confusing, but I believe what they're saying is this. So greater than, so we want, of the Propel kids, what percent got 3.0 or higher? And then of the non-Propel kids, what percent is 3.3 or higher? So we have to look at our specific sample sizes. So that means 61 3.0 or higher out of the 109 versus 218, versus 95 out of 218. And between the percentage. And then we just got to calculate these as percentages and take the difference. And this makes sense because this actually would answer the question, hey, did this thing work? Meaning which one is, where do we have a greater percent of kids getting these higher GPAs? 61 divided by 109 is, of course, this guy. So we'll say approximately, let's say approximately 56%. I'm going to approximate here, but I'm not going to approximate on my calculator. I'll give us the rawest answer. And then, well, here, you know what? Let's just do it all in one fell swoop. Let's do 95 divided by 218 right here. So I won't know the exact percentage here, but we'll just go straight to the difference. And it's about 12.4%. So about, let's say 12%. But if you want to see that one, it would be 95 divided by 218. So this is about 44%. And then we can again see, like normally I don't round to the end, but even in the rounded version here, it looks to be 12. Of the students enrolled in Propel program, so of the students in the Propel program, now we're limited to the subset of 109. The ratio of boys to girls is 2 to 3. Which of the following is the best estimate of the number of girls enrolled in the program? Now, here's how we do it. And there's a number of ways to do it, but I'm going to show you a little shortcut. So this adds up to a total of 5, okay? And then I want to get, and we're talking about approximation, right? So I want to get, if I can get this total number of the ratio up to, actually, I could do it one of two ways. I could say 3 out of 5 equals X out of 109. You know what? Let's do that. I'll show you the other way afterwards because this is the standard way. So 3 girls out of 5 would equal X out of 109, and we cross multiply. And I get 327 equals 5X, then divide by 5. 65.4. All right. So there it is. And that makes sense. So more than half are going to be girls, right? 44 should be eliminated anyways, and we're good to go. The other thing I was going to suggest is like when I know this total is 5, I was going to multiply, 5 times what gets me as close to 109. It's 22, right? So then to get the answer, all I got to do is take the girl and multiply by 22, and I would have gotten 66, pretty close to 65. That was what I was going to otherwise suggest, but good old proportion is good as is. 24 minutes to go, and we're on 19. Doing okay. An artist is creating, okay, I may have to pick up the pace. An artist is creating a sculpture using bendable metal rods of equal length. One rod is formed into the shape of a square. Another rod in the shape of an equilateral triangle. If each side of the triangle is 2 inches longer than each side of the square, how long? Of equal length, got it. One rod is formed in the shape of a square. No. If each side of the triangle is 2 inches longer than how long in inches each rod? I can plug and chug and figure this out, or I can make an equation. The perimeter of the square is the same as the perimeter of the triangle, right? And now I can just solve for x. Distribute. I got 4x equals 3x plus 6. Subtract 3x from both sides. Well, I shouldn't write it like that. Let's write it out. And I get x equals 6. So if x equals 6, the entire perimeter is 24, right? Because then that side would be 6. This would be 8 by 8 by 8. Boom, done. Number 20, a rational function is defined above. Which of the following is an equivalent form that displays values not included in the domain as constants or coefficients? What are they talking about? These problems can be so confusing. But if we know that they're saying, hey, that displays not included in the domain, meaning values that are no good, we're talking about things that make the denominator go to 0. So I want to see the denominator factored properly so I can find what will turn it into a 0. I see it factored very nicely here. And that means the denominator can't be x can't be -2 or +1. That's going to send it off to dividing by 0, which obviously we can't do. So this one, I don't even know what this is. Perhaps simplified or something. I don't know what this one doesn't make any sense. I don't know what this one is. Yeah. So they factored out 2 up top. Here they factored out a 2. And they got x squared plus x minus 2. And then they did that. Anyways, hope that made sense. Number 21. A landscape designing a rectangular fountain with a 4-foot wide path around it. Okay. The equation A equals 4P plus 64 will relate the area A in square feet. Hold on. The equation A equals... relate the area in square feet of the path to the perimeter of the fountain. Okay, just trying to wrap my head around it. So this is the... I'm going to use a different color here. This is the perimeter of the fountain, the inside thing. Okay, and then... this 4-foot wide path, whatever. So this outside thing is the area. Think about it for a second. Okay. In design, how many feet will the perimeter of the fountain increase for each additional square foot of? In the design, how many feet will the perimeter of the fountain increase? Oh, I don't even have to do this. How many feet will the perimeter of the fountain increase for each additional square foot of the path's area? 1/4. Okay, let me show you why. This, I don't have to draw, I don't have to calculate anything. Now, this is how I like to approach these, but I did it mentally. We're going to just make a table, okay? We're going to say perimeter, and we're going to say area, and we're going to plug and chug. Watch. I believe I did this right. So if I plug in, for example... a area value, let's do it like this. An area value of 68, I'm kind of doing it backwards, but then the perimeter would be 1. Because 1 times 4 is 4 plus 64 is 68. Now, they said, how many feet will the perimeter increase for each additional square foot? Well, let's test it out. Now let's see what happens. If I plug in 69 now for the area that's going up a square foot, now we solve for P. Subtract 64 from both sides. 65 equals... what am I talking about? 5 equals 4p. Divide by 4. Divide by 4. And it equals 5/4, a.k.a. 1.25. A.k.a. it went up a quarter. Number 22. In the xy plane of the graph function Q is a parabola. If the graph intersects the x-axis, let's draw a quick sketch just so I have an idea. So here is -1, 0. And R0, vertex of Q occurs at 0.24. So here's 1, 2, 2, 3, 4. So of course it's going to be going down like this, right? And this means that R is going to be somewhere over here. So now I get a really nice idea. So something very special about the vertex and the x-intercepts. It's always right in the middle. It's perfectly symmetrical. So if this is -1 on the x-axis and this is 2 on the x-axis, that's 1, 2, 3 apart. So to get the other x-intercept, I have to go 1, 2, 3, and it's at 5. 23, liquid going, and lots of different ways to solve this. You could come up with the equation of the parabola if you want, but I think this is a really good way. Liquid going through a cooling system is chilled so that its temperature decreases at a constant rate from 100 to 25 in 5 seconds. So temperature and time. So 100 times 0, 25 times 5. Which functions represents the temperature C in degrees Celsius as a function of the time after chilling began from 0 to 5 seconds. So it would be should be a y-intercept of 100. Oh, wait, sorry. Hold on. Yeah. And then, wait a minute. Is it just C? C is so obvious. Wait. It's too obvious for this late in the game, but I think it's, I think it's D. Sorry, did I say C? I think it's D because it's 100 minus 15t. It's the only one with the right y-intercept. But hold on. Let's contemplate this for a second because I'm a little suspicious. Liquid going through a cooling system is chilled at a temperature decreases from constant rate from. So it should be dropping by 15 every second. That makes sense. 15 times 5 is 75. As a function of which of the following functions represents the temperature in degrees Celsius in seconds after chilling began? I don't see why it's not. First of all, C and A are rising, and this one would decrease to like something negative. It doesn't make sense, so it's got to be D. But it's pretty straightforward, and it was pretty easy to eliminate answers. So let's just hope I didn't miss something. The formula for the volume of a sphere with radius shown above the radius of the planet Jupiter is about 11 times the radius of the planet Earth. So if that's Earth is x, Jupiter's 11x. Assuming the planets are spheres, about how many times larger is the volume of Jupiter than the volume of Earth? Okay, so let's plug and chug and just kind of see what we get. So for Jupiter, it'd be 4/3 pi, and then 11x cubed, which is, I don't even know, what's 11 cubed? And then it's 1331x cubed. And then this one would be 4/3 pi x cubed, okay? Everything else is the same, so everything else is irrelevant. I don't need to take 4/3 of this. I bet you 1775 is 4/3 probably, but I don't need to do that because literally they're the exact same except for this 1331. That's the winner. 25, the population. We're almost at free response. No, we're not, actually. Never mind. The population of squirrels in a park has been doubling every 15 years. Which of the following statements best describes the type of function that miles... Okay, so it's been doubling. So it's exponential. Okay. So when it's doubling, it's exponential. 2, 4, 8, 16, 32. Linear would be 2, 4, 6, 8, 10, right? Constant rate of growth. Because the population of squirrels is increasing. It's not increasing by the same amount, by the same percentage, aka 100%. Increasing by 100%, if that makes sense. If function f is defined by this, what is f of x minus 4? All right, all I'm going to do is nicely replace every instance of x. This is just good old function notation. We're subbing in x minus 4 in for every x. X minus 4 squared minus 5 times x minus 4. Plus 4. Okay, then we're going to distribute 5. Oh, negative 5x. Whoops. Negative 5x plus 20 plus 4. And then let's FOIL this one out. Remember, it's x minus 4 times x minus 4. It's not x squared plus 16. It becomes x squared and then negative 4x, negative 4x. Let me just write it so you know what I'm talking about. Negative 4x is negative 8x, and then plus 16, right? Negative 4 times 4. Now we distribute this guy. 3x squared minus 24x plus 48. Now we combine like terms. 3x squared.
These combine to make negative 29x. And then that becomes 24. And then plus 48 is 72. No 72. Negative 29x. D is the winner. Done. Moving on to 27. The equations of two lines are shown above. If the lines are graphed in the xy plane, which of the following ordered pairs represent the point at which the lines would intersect? Sorry, the equations of two lines are shown above. If the lines are graphed in the xy plane. Okay, we're just solving a system of equations. I can do substitution. Wait, hold on. Okay, I'm just trying to think of a shortcut. Now, I am not a fan of plugging in fractions and all this, but I gotta work around. Watch this. You see how I've got 4y down here? I could either just multiply this by 3, or I can multiply the top equation by 12. Because what's 12 times 1/3? It becomes 4y. Isn't that nice? Now I plug in 12x into 4y, so it's literally 154 minus 12x equals 10x. Add 12x to both sides, and I get 154 equals 22x. So I know my x value will be probably 7. X value is 7. Boom, done. I don't even need to check, but now I can double check up here. 7 equals, and then 21, 1/3 21 is 7. That works. And then here, if I plug in 7 for x, that's 70 over there. 4 times 21 is 84. 154 minus 84 is 70. 70 equals 70. Boom, done. 28. And then we get the free response. Yeah. A grocer carries 2 types of frozen meals that have the fat and carbohydrate content shown in the table above. 4 fat, 20 carb, 5 fat, 35 carbs. A grocer carries 2 types of frozen meals that have the fat and carbohydrate content shown in the table above. John wants to purchase a combination of 2 types of meals. Combination of 2 types of meals with no more than 350 grams of fat and no more than 275 carbohydrates. If John purchases 10 Szechuan chicken meals, what is the greatest number of stir-fry meals he can purchase so the combination will satisfy the requirements? So he needs 350 fat, or no more than 350 fat, no more than 2975. And right now, he's already got 350 carbs and 50 fat. So that means so stir fry, we can get 300 because we already got 50. So 75. So I could purchase, according to the fat, I could purchase 75 stir fries. But then now we have to see according to the carbohydrates, because if that's less, then we have to tap out at the carbohydrates because we don't want to cross either. So then we've already got 350. So 2975. Hold on. Minus 350 is that. So it's 2625 to spare. Let me divide it by 40. And I can get 65.625, but it's going to be 65. So the max is going to be the lesser of the two, which is 65. While 75 will get us right to the threshold for fat, it's too much for the carbohydrates. All right, 29. If xy is the solution to the system equation above, what is the one possible product of x and y? Got it. So we solve, and that's that. So all I'm going to do is do a little substitution. X minus 1 equals x. Make sure timer's good. X squared minus 4x plus 3. Subtract x from both sides. Add 1 to both sides. 0 equals x squared minus 5x plus 4. Factor, good old-fashioned factoring. X, -1, -4. Why? We want to know what multiplies the positive 4, what adds to -5. Those two guys, which means my solution for x are 1 and 4. So we have two solutions. They said, what is one possible product? Let's just plug in 1 and get my y value. If I plug in 1 for x, I get 0. So one solution is 1, 0. The product would be 0. Let's just do the other one just for fun. The other one would be 4, plug 4 in for x, 4, 3. So the other product would be 12. Let's just go with 12. And then let's just double check up here. 4, 3. If I plug in 4, it's 16 minus 16, 0 plus 3 is 3. So yes. 30 and 31. King crab supply. This is our 2-part question, which are always pretty much at the end of these free response for the calculator section for the main SAT, I mean. But king crab supply from 2005 to 2012. The king crab shows the supply of millions of pounds of king crab harvested and sold from 2005 to 2011. The information for 2012 is not included in the graph. Got it. Okay, so it looks like it's declining, right? So in the year of 2005, it looks like we're at around maybe 65, maybe 180, 165. This looks like 125. I don't know, somewhere in that zone, right? In 2006, the price of king crab was $8 per pound in the beginning of the year and dropped to $7 by the end of the year. So 2006, it was 8 at the beginning of the year and 7 at the end of the year. If 60% of the king crab supply was sold at the higher price per pound, 60% at 8, 40% the remaining at 7, what was the total revenue generated in millions of dollars from the sales of king crab? Got it. Okay, so let's get that exact answer for 2006, right? So we said that one's nicely 180, so that's nice. 60% of, this is pounds, or what is this? Hold on. In millions of pounds. Oh boy. All right. Oh, in millions of dollars. So we just ignore that. I don't have to put a huge number in. Wouldn't even fit anyways in the grid in, right? So 60% of 180 should be 108. And so that's 108 at the higher price. 108 times 8. And then the remaining would be 72 at the lower price. And then that's the total revenue. So we add those two guys. Let's just make sure. 0.4 times 180. And then we got 72. So 108 times 8 plus, just put parentheses just to be safe, 72 times 7 equals 1368. And we're good to go. Timer. We got 7 minutes left. We're great for the final question, right? In 2011, the price of king crab was 17 per pound. So again, I'm going to mark the graph. In 2012, X million pounds, so X, so let's just say X for 2012, were sold at $16 per pound. So 16X is how much money the revenue was. If the total money generated from the sales of each year was the same, what is the value of X? Which means 16X would also equal 17 times my 2011 value, which is 80. Yes. Look at this. We got a nice little equation. 17 times 80 is 1360. 1360. This contradicts what they earned in that other year, but let's just ignore that. Because it said every year, but that's all good. And then 1360 divided by 16 is 85. Now, maybe I got this wrong. Maybe that's what this is telling me, but I don't think so. I think it's just they didn't think it through. So 8 times. So hold on, let me make sure. In 2006, the price of king crab was $8 per pound at the beginning of the year and dropped 7. 60% of the king crab sold at the higher price. 60%, 108 times 8, 864. 864. And then that is, and the rest was sold at the lower price, 7. That's 490 plus 14 is 504. Yeah, that's 1368. Okay, anyways, that's just kind of funny. But let's stop the timer. We got 5 minutes to spare. Pretty solid. So I'm going to grade the test, and then I'll do my best to take some questions here. And by the way, if you are just tuning in and you missed what I announced at the beginning, we've got the official Discord up and running. So if you guys do want to join and really take your SAT, ACT, whatever math prep to the next level, join. Check the invite link in the description. And let's do this together. Okay. So we've got, let's see here. Oh yeah, scoring guide. B, A, B, D, B. B, A, B, D, B. 6 is A, B, C, A, D. A, B, C, A, D. Nice. 11 is D, A, B, C, C. D, A, B, C, C. Oops. 16 is B, D, B, D, C. B, D, B. Oh, yeah. 19 is C. Wait, did I miss one? And then B. Got it. 21 is B, D, D. B, D, D. And then we've got 24. C, B, D, D. C, B, D, D. Nice. Excellent. 28. Let's do some free response. Here we go. 65. Yes. 0.12. Oh, 0 or 12. I was like, what? 0.12. Okay, good. And then we got 1368. Yes. And for the win, 85. All right. Sweet. Very nice. Hope that was helpful, guys. For those of you who are taking this PSAT tomorrow, let me see what we got here. Can you go over constants? Yeah, I mean, a constant is just a number. That's it. And if you, again, you should really watch my critical concepts SAT math video because that will explain it very well. Here, let's go over here. Let's go to my channel real quick. And so what I'm talking about are these videos, like the Heart of Algebra. If you look at this one, I talk about the constants. I think even in Passport to Advanced Mathematics, I talk about what the constants mean for, for quadratics and stuff like that. So if you have questions, honestly, this is what you got to watch right there. Practice this as a SAT. Yes, this is PSAT. This is great for practicing SAT as a thing. So, okay, appreciate what you're doing, man. You're welcome, Nathan. Any tips for reading, writing, and language? Yeah, I have a video on my channel. Also, look it up. Olivia, one of my tutors, she gave some great tips for that section. It's like the actual SAT. What are the differences? And yeah, PSAT honestly is just to get you acclimated. Try it out, see how you do, and then you can develop a test plan after that. Can you do a video of the actual SAT? Oh, well, you must be new to the channel because I've got tons of videos where I do actual SATs. I don't even know how many, but again, if you look at my channel. Look, I've done all the college boards. I've done real tests. I've done College Panda. I mean, the list goes on and on. There's some ACT stuff, but you just got to go to my channel and check it out. And thank you guys for the likes, by the way. If you did like this video, feel free to hit that like button if you haven't done so yet. And can you continue SAT tests? Absolutely. Well, hopefully, again, these critical concept videos, for those of you guys who are refreshing your memory and getting that all back in your repertoire, those are the videos. Can you solve some ACT tests? Yeah, absolutely. I will do more ACT math. And I know there's an ACT coming up, so I'm going to do a big, long, lengthy series on ACT math as it gets up. Okay, amazing. Thank you guys for joining. And I was watching one of your do you figure out whether the standard deviation is the same? Yeah, any standard deviation. Oh, thank you, Marissa. Any standard deviation stuff, you don't have to actually know how to calculate it. Just know that if you see standard deviation, and this is again in the critical concepts and the additional topics in math, problem solving and data analysis video. You should check that out. But again, you just got to know that one thing, standard deviation is the measure of spread of data. If it's more spread out, the standard deviation is larger. If it's more tightly packed, all the values are really similar and close together, then it's a smaller standard deviation. That's it. Okay, guys, the College Panda stuff, I'll definitely start working on it before March, but I got to finish this pawn, the SAT section. That's my first priority. Thank you guys so much for joining. And again, if you check out in the description link, check out my Discord. So hopefully I'm going to log off here and I'll see a bunch of you guys trying to join, and that's going to be exciting. And then we're just going to keep working with it. We're going to build an awesome community of champions who are striving for excellence in ACT, SAT math, whatever it is, whatever it may be, IC math, that stuff, so on and so forth. Because I truly believe now in this digital revolution for ed tech and education, the power is now with you guys. And I'm seeing time and again folks that may not have all the resources that everybody else has, but they have the will, they have the hunger, and now there's digital resources, free resources, communities, places where people can support each other, and you can really shine and do amazingly well. Just remember, these tests, while they like to pivot, while they like to advertise them as intelligence tests, they are really skills tests, and that means you can learn the skills and master the test. And so it's a challenge, just like an athletic event, that can be overcome. So that's what it's all about, and I wish you all the best of luck. Yes, I have in-depth geometry videos. Again, if you're trying to learn the math on the SAT, this is where you got to go, right here, this video series. It will give you everything, okay? I worked super hard on it. It's almost 3 hours of content. That's it. That's the deal. Okay. Thank you guys so much, and I will see you in the next video.